My old bathroom fan gave up the ghost a few months ago and I was going to do a quick like-for-like swap, but then I realised, as so often happens, that this wouldn't have scratched the surface in terms of all the things we should be thinking about when installing or replacing a bathroom fan. So today's video will be divided into two sections. Section 1 is the theory, why you need a bathroom fan in the first place and what you can do if you haven't got one, how to choose a bathroom fan. I'm going to be talking about extraction rates and how fan size, ducting and backdraught shutters are something you need to think about. And I'm also going to be touching on a few electrical issues. And in the second part of this video, I'm going to be comparing two axial fans. The best in class Silent Tornado against Axia's brand new Svara smart fan. I'm going to be showing you which one I've decided to install, and I'll also be throwing the fantastic turbo tube inline fan into the mix. And I'm going to be giving you a couple of simple tests to check to see whether your fan is working. And finally, as usual, I've had some incredibly valuable feedback from you guys, and I'm going to be weaving that into the video wherever possible. I'd just like to say a massive thanks to all of you who have either bought me a coffee or become members of my Buy Me a Coffee channel since its launch. The Discord chat forum is going from strength to strength and I've got some really exciting additions on the horizon. And don't forget, this month's free giveaway is a deck cleaning and treatment kit worth £109. You can find a link to where you can sign up on my YouTube channel homepage and in the description below this video. Quick word before I start. The three fans featured heavily in today's video have been provided to me by Extractor Fan World, where I bought all my previous fans from because they're very efficient and good at honouring product warranties. I was on the phone to them buying this fan and cheekily mentioned to the marketing department about this video, and they kindly provided me with the three sample fans in today's video free of charge. But I stress they haven't paid me anything to mention them in today's video. However, special thanks must go to George at the company for providing me with so much of the information that I've used in today's video. I'll post links to those resources in the description below the video. So do you actually need a bathroom fan? Well, if your bathroom has an openable window, then strictly speaking, you don't, under building regs, need to install a bathroom fan. But they are generally required in new builds, especially where natural ventilation isn't sufficient. So when I did a refurbishment of this room a few years ago, even though I've got this in the shower and also this window above the bath, I decided to put one in, not least because although I'm a vigilante about keeping moisture levels down around the house, the rest of my family aren't, and it's quite hard to persuade them to leave the windows open, particularly during the winter. Now, I'm not going to go into any real detail on moisture and condensation in today's video. I covered that comprehensively in this video coming up on screen now, but suffice to say, cooking and bathing produces massive amounts of moisture. And in fact, we breathe out half a litre alone ourselves each day. And all that moisture in the air can lead to mould, damage to the fabric of your property and health problems. So if at all possible, you want to keep the relative humidity levels in your house below 60%. But if you have got a window, keep it open whilst you're having a shower. And if you can, get yourself a squeegee or a Karcher window vac. And in fact, I've noticed that Screwfix are doing a Titan window vac for just £25 at the moment. Because I squeegee down this shower area, including the tray and the tiles, each day after I've showered, which removes a whopping 200 ml of water that would otherwise have circulated around the house. And some of you have told me you keep your Karchers permanently in the bathroom for this reason. But if you haven't got a window or a bathroom fan, consider getting yourself a dehumidifier like that 3850 E-Back you would have seen in that video, as this will quickly remove any residual vapour after bathing. And even better, if you have no option but to hang up all your clothes around the house, which also sends a whopping amount of moisture into the air, that E-Back is an absolute godsend because you can put it into laundry mode to suck all of that moisture out of your clothes into the dehumidifier. Obviously, other compressor and desiccant dehumidifiers are available. I simply mentioned the E-Back because that's what I've got. So how do you choose your fan? Well, there is quite a lot to think about here, not least because there are so many different fans on the market. But break it down and it becomes reasonably straightforward. And when you understand which types of fan are available, you can work out which one is most appropriate for the space you've got. So first up, we've got the axial fan. And they're designed for installation directly through an external wall or ceiling on a very short duct. Air is pulled through the impeller or fan blades and ducted straight through the wall. And these are what you typically think of when you imagine a bathroom fan. They look great, and depending on how much you spend on one, you're going to get an extraction rate of somewhere between 70 and 110 cubic meters per hour. More on that in a minute. They typically have different switching options from pull cord timer, humidistat to occupancy sensor, but crucially they are limited to very short duct runs. So what do you do if you haven't got an external wall or a convenient place to put the fan, or you've got a long duct for it to ventilate down? Well, in this situation, you've got two options. So option number 2 in your list is the centrifugal fan. Whilst the designs vary, some of these fans look similar to axial fans, but they're a bit more bulky and generate far greater pressure. So where the industry-leading axial fan can extract between 95 and 110 cubic meters per hour, centrifugal fans can pull out between 80 and 216 cubic meters per hour. So they're ideal for bathrooms with no external walls and where you need a longer ducting run. And they typically have more switching and operating options than an axial fan. But in my view, they're a bit ugly with that bulk, so you wouldn't want to have one of these fans on show. Which brings us on to the third option, this mighty beast, the inline fan, which looks more like something you'd see in a plane than in a house. And it trumps your humble axial fan both in terms of size and also weight. These fans are basically your best option if you've got room in your loft or a ceiling void to install them in. They're 3 times as powerful as an axial fan and they sit within the run of ducting, so you don't have them in your bathroom and so you're not going to hear them operating. The extraction rates go up to a whopping 245 cubic meters per hour. They're great for installations where you've got a much longer ducting run or where you suffer from serious mold or condensation problems. And being in the loft, they're the quietest of the 3 options. And the other point that could be really important for you, because you've got no electrics in the bathroom because this is in the loft, you can position the inlet duct for this fan wherever you want in your bathroom. And we'll come on to bathroom zoning in just a minute. And in case you're wondering how the vapor that's extracted from this goes outside, I was intrigued by this as well. And so I bought this plain roof tile vent which fits with my existing tiles. It basically replaces 3 of the tiles on the roof. And then you combine that with a vent adapter and flex pipe. Extraction rates are to an extent dictated by what's under the bonnet in the fan, which is why you get extraction rates in 4-inch spigot fans varying between 70 cubic meters per hour and 110. However, the diameter of the spigot at the back of the fan is the main driver on extraction rates, particularly with axial fans like this where there is a real ceiling on the extraction rates of the fan. Most bathroom fans have a 4-inch or 100mm spigot, and I believe the current industry leader is the Axia Svara, extracting 110 cubic meters per hour. But you can also get 6-inch or 150mm spigot fans, more typically seen in kitchens, but with an IP rating that enables them to be fitted in bathrooms. And in fact, when I polled my YouTube subscribers on a community post about this video, Aaron came back and said he had fitted 150mm Axia in his previous property. I'm guessing it was this one, and it was activated with a humidity sensor, and apparently the air movement created by the fan was powerful enough to shut the bathroom door. And that 150mm Axia shifts a whopping 241 cubic meters of air per hour, more than twice this silent tornado. In his new property, he fitted a 100mm Axia fan, and he said it was nowhere near as good. And Swills chipped in to say that the difference between 100 and 150mm spigot fans isn't just a linear 50mm, it makes a massive difference to static pressure, which greatly affects the performance of the fan. And you've also got the ducting to consider, more on this in a minute. So that's just something you should consider if you're wondering what size ducting to fit in your new bathroom. But as usual, there are other things you have to consider. With a sound rating of 43 decibels, it's nearly twice as noisy as the silent tornado, which has a 25 decibel rating. So maybe the best thing to do is a quick calculation so that you can work out what extraction rate you really need in your bathroom. So taking my bathroom as an example, the room volume is 21.25 cubic meters. So to change the air in my bathroom, the fan needs an extraction rate of 21.25 cubic meters. However, building regs requires a rate of 4 air changes per hour. So we multiply 21.25 by 4 to give us a total rate of 85 cubic meters per hour. So given I have an axial fan installation, the 2 fans I'm going to show you today, the Axia Svara at 110 cubic meters per hour gives me just over 5 air changes, the silent tornado 4.56 air changes, and the inline fan, or that Axia silhouette we just looked at, a whopping 11.5 air changes per hour. So these are the extraction rates for a typical axial, centrifugal or inline fan. But these extraction rates assume optimum conditions. As soon as you introduce ducting, the extraction rates will decline. And the type and length of ducting that you use will have a huge bearing on the efficiency of the fan. As one of my regular contributors, Norman Boyce, pointed out, and thanks Norman for this, minimising turbulence and resistance to flow in the ductwork is crucial. The cheap plastic ducting causes losses, and the best is rigid PVC with short lengths of flexible only for the connections to the fan and the outlet terminal. Also, as George at Extractor Fan World said to me, as well as crinkles or holes in the ducting causing decrease in the extraction rate and mould from the condensation, any 90-degree bend you put in the ducting effectively adds an extra metre to the overall length of the duct. So you want your ducting to be as short and efficient as possible. And remember, flexi hose ducting like this can cause water traps and therefore build up of mould. And in the case of the metal flexi hose that I installed for our tumble dryer, I've had a real problem over the years clearing out the fluff that gets caught in the hose. So for an axial fan, you really want to install rigid plastic PVC pipework like I've done here and have it sloping down slightly from the fan to the outside. And for inline and centrifugal fans, as Norman said, for your ducting, use PVC pipe wherever possible and limit the flexi to the connections to the fan and outlet terminals. In terms of installing the ducting itself, for that tumble dryer, I did actually hire a core drill, but the Victorian bricks I was trying to drill through were fired to within an inch of their lives. They're almost like engineering bricks. Complete nightmare to get through. It took me absolutely hours. So what I do these days is with the chisel on my SDS drill, I just fracture through a couple of bricks, as I did here when I was installing the bathroom sink waste. It takes a matter of minutes, so easy to do, and you can make good any damage caused by using bits of the bricks you've excavated and some sand and cement. So the third thing that has an impact on extraction rates is the backdraught shutter. And whilst this is an important addition to the installation to prevent cold air or wind flowing back into the bathroom, particularly in the winter, and also particularly for inline fans which don't have a backdraught shutter incorporated, there are certain things you need to be aware of. So axial fans often have the backdraught shutter built into the back of the fan like this. A lot of people take these off thinking it's flimsy packaging, but it's not. And the flimsy design and the fact that it's fitted so close to the exhaust end of the fan makes it very efficient at preventing cold air coming back into the room whilst not substantially reducing the extraction rate of the fan. And in spite of this flimsy design, you can see the backdraught shutter still in place and going strong in the old Silent Tornado fan I'm replacing. But being this flimsy, it does make a bit of noise and I hear it clicking quite often in the wind. But as I've decided today to install this Svara fan, which as you can see doesn't have a backdraught shutter, I do need to look at the options to see which is the best one to install. Backdraught shutters like this wall cowl that sits at the end of the ducting run are going to have a dramatic impact on extraction because the air won't be travelling as fast at the end of the run as it was when it exited the fan. And I think the gravity grill on this one is too heavy and the build quality is poor. It arrived damaged and the shutter hinge is snapped, and you see this a lot on online reviews. I've also seen online reviews that say the gravity grill is stuck and needs modifying before the shutter can be used. This inline backdraught shutter is probably best. I thought it was a non-starter for me because you have to obviously install it within the duct, and I've got this rigid PVC duct already in place. But I found out that actually it will insert inside of the existing duct. I'm not going to use this today, and it will create a little bit of extra turbulence, not being completely flush, but it could be a lifesaver in the winter if I find there's too much cold air getting into the room. And I bought this Blauberg sound baffle vent cover, which is great quality but absolutely massive and won't fit under my eaves. So the shutter I've ended up installing is this Energy Saver grill. It's decent quality, stops the wind getting in without reducing the fan's efficiency in the way that one of those gravity shutters would. And whilst it does let cold air through, in pretty blustery conditions, so far it's doing a good job. One last point to consider before we move on, air starvation. If you think about it, a fan is extracting all this air out of the room. If you don't allow more air into the room, the fan will become suffocated or starved of air. And a lot of people complain about this when they've upgraded to a more powerful fan. So it's important to allow fresh air into the room. You can either do that with a passive air vent or alternatively make sure there's a sufficient gap under your bathroom door. And so we're on to electrical considerations, and the first thing I want to talk about briefly is switching modes. Bathroom fans are typically wired into the lighting circuit, enabling you to switch them on when you turn on the lights. Depending on how they're wired, some will switch off when you turn off the lights, and some will be wired slightly differently, enabling the fan to keep running when you switch off the lights, either via a humidity sensor known as a humid stat, or by a simple timer. For these fans with an overrun function, you typically need a 3-core and earth cable supplying the fan, with one of those wires becoming a switch live. Although the Axia Svara only needs a live and neutral for its overrun timer, which means if you've only got a 2-core and earth cable, you can install the Svara without an expensive rewire. Humidistat sensors are a great way to keep the bathroom air as dry as possible without excessively overrunning the fan. You can also get fans with pull switches, although those are more rare these days, and with PIR motion sensors. Clearly, if your fan is to be triggered by humidity or motion, you don't need it wired into the lighting circuit. You can instead have it wired directly from a fused spur. And this brings us neatly onto isolators. It's a really good idea to have your fan on an isolator switch in an obvious location near to the fan, often located outside the bathroom on the wall, or if located inside the bathroom outside of zone 2. And I think in this situation the lighting circuit has to be protected, as mine is, by an RCD. The isolator allows you to switch off the fan whilst leaving the lights on, which is a crucial safety measure for your electrician when carrying out repair and maintenance of the fan. Whilst fan isolators are often not fused, increasingly manufacturers are specifying that their extractor fans should be protected by a 3-amp fuse. Now, opinion in the community is divided on the need for a 3-amp fuse, but I can see a couple of points here. As one of my Buy Me a Coffee channel Discord forum members pointed out, a lot of houses still have those old-fashioned BS3036 rewirable fuse boxes. The fan manufacturer doesn't know what sort of fuse box you've got, so it makes sense for them to want to protect their fan with a 3-amp fuse. And my second point about the 3-amp fuse is that a lot of people say this isn't a building regs requirement, but I'm not sure that's right. And again, an electrician on my Discord forum pointed out, it's stated in BS 7671 that accessories must be installed in accordance with manufacturer's requirements. So if the manufacturer requires a fuse, you've got to install one to comply with building regs. But what work can us DIYers actually do? Well, whilst on the face of it, a fan replacement doesn't constitute a change or alteration to an existing wiring circuit, which is notifiable, which does require Part P certification when carried out in a special location, special locations being the area shaded green on this visual, there are a few problems with us DIYers replacing our own fans. Your fan instruction manual will make a big point about the fact that all electrical work must be carried out by a fully qualified electrician. And with good reason, because any electrical work carried out in zone 1, we'll come on to the zones in a minute, carries with it a lot of dangers. The wiring to the fan will need testing with a professional tester, which can cost up to £600. And the RCD will need testing to make sure it's tripping correctly. And dare I say it, whilst this fan is double insulated, so must not be earthed, the earthing in your bathroom should also be checked. So for these reasons, I just can't recommend that you replace your bathroom fan yourself. For peace of mind, get a qualified electrician involved. Which brings us neatly onto the final part of this section of the video, bathroom zones. Where you install your fan is a combination of electrical safety and common sense. Zone 0 is the interior of the bath or shower tray. Zone 1, the exterior of the bath or shower tray to a height of 2.25 metres above the floor. And Zone 2 extends to 0.6 metres beyond Zone 1 to a height of 2.25 metres above the floor. Now, it's best to fit your fan in Zone 1 closest to the source of steam. And so the location of my fan on the wrong side of the glass shower screen is not ideal. But to do this, the fan must be low voltage, or 240 volt appliances must have a minimum IP rating of 44 or higher, and a 30 milliamp RCD, or residual current device, to protect the circuit. Low voltage fans don't require an IP rating, but they're trickier to fit because the transformer for them either has to be hidden in the wall or located outside Zone 2. So it's widely considered to be easier to install an IP rated fan. So the IP or ingress protection rating basically denotes the zone the fan is suitable for. The first digit describes its protection from solid materials, and because that's not particularly relevant in bathrooms, you typically see it substituted for an X, so IPX4 or IPX5. And the second digit refers to protection from water or moisture. And whilst the silent tornado we're going to look at now is IP45 rated, which includes protection against low pressure water jets, the Axia Svara is IP44. So I'm now going to show you the 3 fans that were featured in this video in operation, and then at the end we're going to run through some of the other fans that have been recommended by you in my community post. First up is this silent tornado. If I hadn't had my head turned by the Svara smart fan, I'd be very happy with this fan. As this is my second of these fans, having originally had an Enviro vent of a similar spec installed when I renovated this bathroom. It comes, as you saw earlier, with lots of switching options. This is the second most expensive behind the PIR version. This having the timer overrun and humid stat, which are each adjustable with the plastic screwdriver tool that comes with the fan. Whilst humid stats and timer overruns typically can be temperamental in operation, either never switching off or perhaps never switching on, I've never had this issue with this silent tornado. And the noise level, well, it's definitely not silent, but I'd say it's quite enough for you to live with whilst it's doing its job. But this is the fan I've decided to install permanently, the futuristic looking Axia Svara. You'll recall this fan only requires a live and neutral, but unsure how I was going to configure it, I had the switch live wired in anyway. The fan also supports low voltage connection. And for cleaning of the fan and ducting, the wall frame and motor unit are much easier to remove than they are on a standard fan. When the fan comes on, the first thing you notice is how quiet it is. At 20 decibels, it's 5 decibels quieter than the silent tornado. You then download the Axia Connect app and run through some basic configuration settings. If you choose to set it up using your light switch to switch it on, it automatically disables the light and humid stat sensor, leaving you with just a basic timer overrun, which I think is a bit of a shame. So I reset the fan and chose the option of not using a remote switch into the switch live. And at this point, you've got two final options: continuous mode, where the fan will go into trickle mode rather than switching off, and intermittent, where it'll operate more like a standard humid stat fan, switching off when it's done. You might as well opt for continuous mode because you can disable the trickle fan in the settings later. And you can boost the fan to full power for up to 15 minutes at a time. You've then got lots of customizable settings like changing the trickle fan speed from 41 to 70%, and you can set when during the week or weekend the trickle fan works, that point I made earlier about disabling it. In run mode though, at 41%, the fan is almost inaudible. And whilst I didn't think I was going to use it because of my backdraft grille allowing plenty of fresh air into the room, I probably will do, because apart from anything else, it will stop flies getting in. You can also adjust the light sensor timer settings and humid stat, the sensitivity of the sensor and how long the timer runs for once activated. There's a 5 and 10 minute delay function when you're only popping briefly into the bathroom, which I think is genius, because how many times have we accidentally triggered our noisy fans in the night? You can also set silent running hours during which the fan only runs on trickle speed, assuming you haven't turned that off, for example overnight, which I think is another big tick. And finally, there are automatic purge cycles to run the fan at full power for 30, 60 or 90 minutes every 12 hours to ensure the air in the room is refreshed twice a day, which I think is another brilliant idea. So are there any downsides to this fan? Well, I'm conscious I've only had it for a few days, so I haven't really had a chance to tease out many teething problems. It connects via Bluetooth rather than Wi-Fi, which initially was slightly annoying, but makes perfect sense. You don't really want to have something like this on a Wi-Fi network. It's a bit inconvenient having to be in the same room as the fan to change the settings, but you're not going to be changing the settings very often. But the main issue I've had is quite an interesting one. You saw at the start I'd had the switch live connected into the fan. The downside of this is, by doing this, it overrides all of the light sensor functionality and triggers every time you turn the lights on. So you don't get that 5-minute delay that I was talking about earlier, detection sensitivity or running time. So if you want this fan to run in automatic mode, you cannot have a switch line connected. I would have thought Axia could have dealt with this through the software, because I could see a problem here with electricians wiring up the 3 cores previously utilised by the old fan for the customer to then find out when the electrician's gone about this problem. Other than that though, I've been really impressed with this fan. And when you compare all of the settings it's got against those of the silent tornado, the tornado looks pretty prehistoric in comparison. So those are my 3 fans, and I'll show you the inline in operation in just a minute. But what are the other options on the market? Well, the best thing I can do is suggest you trawl through the excellent comments that were left in response on my community post. For example, for another smart fan option, James and Carl recommended the Zender, formerly Greenwood, CV3. But just look at the price. Ricky and Julian really like that EnviroVent I showed you earlier, and the manufacturer doesn't require a 3-amp fuse protection with that. And Justin and Jonathan both have the Airflow Icon fans with their camera style shutter. Available with pull cord, PIR, timer and humid stat modules. Paul adds that the iris closing completely eliminates backdraft, and also with this iris you get none of that clanking in the wind that you get with so many backdraft shutters, as I was explaining earlier. And there are various other recommendations that I just haven't got time to mention. I promised at the start that I'd talk about how you can test to see whether your extractor fan is working. You probably saw just how dusty my old Silent Tornado was, and I suspect this was in part the reason for it failing. So try and clean your fan as often as possible. And to test whether your fan is working, the most effective test is to hold a tissue in front of the fan and see if it sticks. And the Svara, I'm not going to test that at full power because it will tear the tissue to shreds, but you can see here, even with the fan running at 40% trickle mode, it's strong enough to hold the tissue in place. And that TT Pro inline fan is strong enough to hold a sock with its suction. This inline fan is just so powerful. So whilst I do love that Svara, I am 100% installing one of these inline fans on my next bathroom project. So that's it for today. That did turn into a bit of an epic length video, but I hope that you've at least found it useful. And don't forget, you'll find in the description below the video links to all the fans I've referred to today and that know-how from the Extractor Fan World website. You can access that description by clicking on the little arrow on your smartphone and the Show More button on your PC. If you've liked today's video, it'd be great if you could click on the like button below, and as I always say, if you're new to my channel, it would mean so much to me to have you subscribe. You can do that by clicking on the link here, and don't forget to click the bell notification icon so you get notified of all my future uploads. Thanks a lot and see you soon.